Okay, I don't remember if I brought this up last class or not, but it's looking like test one is going to be on February 10th. I think maybe I mentioned that was a possibility last time. Don't really remember. That looks pretty solid. That's what we'll be. Just so you know what to expect as far as how that'll work, I will put a practice test on WebAssign ahead of time, and then so is the 10th. Is that Thursday? Yeah. So that Tuesday, February 8th, will be review day. Okay, so we'll just work through the practice test in class on the 8th, and then whatever questions you want to ask, you can go through that, and then we'll have test on the 10th. Okay. So, I think we've got 2 more sections after we finish this one. So 2 more sections after we finish this one. So that's what we'll do next week, and then Tuesday after that we'll do review, and then Thursday after that will be test 1. Oh, yeah. Anybody have any WebAssign problems giving you trouble? Need to talk about? Haven't got too tripped up on any yet that we haven't already talked about? No. Okay. So let's try to remember what we're doing. Oh, sorry, do you have one? Oh, yeah. So it depends on, is it when you have a fraction? Is that the main? Okay. So let's make one up here. Do this off to the side. There. So if you have something like so if you got something like that, is it? Yeah, if you give me what you've got, I will do exactly the one you're working on. She's asking about if you have a fraction involved, how do you just go back over one more time on how to split that up into a plus bi form? We'll do this one. If you find that one, just let me know. We'll do another one. Okay. So essentially what we're doing, if we have something like this, right, they won't take that as our answer if it says put it in a plus bi form. So essentially what we're doing is we're kind of going in reverse from if you have a fraction and you're trying to get a common denominator so you can add things together. An equivalent way to write this expression is to take each term on the top and put it over the denominator. And then the I you can put out to the side. If you had, something in reverse order, you'd have to switch it around as well. And sometimes things will simplify. Like on this one, if we write both terms over 9, the negative 3 over 9 part would simplify a little bit, right? 3 would go into both of those. That would just give us negative 1i over 3 plus 1/9. And then finally, okay, last little step we rearranged. The 1/9 would need to go in the front. And then if we move the I down to the side, that's negative 1/3 I. So that's what it would want on that one. Okay. Sign-in sheet, make it all the way around. Bring it over there. Save you from having to remember. Does that help? Maybe you got one? Oh, okay. All right, I got you. So we're going to do something like that today. So if that doesn't help, let me know. Yeah. So, I had one with a radical involved too. Yes, we're gonna. Yeah, we gotta do discriminant today. So yeah, we're okay. We didn't finish this section today, so don't panic if you don't know what the discriminant is. We just haven't talked about it yet. Okay. So that's good if that's where you are on the assignments, and we're in good shape. Okay. Yeah, let's go ahead and do that. We'll go ahead and talk about the discriminant. So if we're working with the quadratic formula, and we've got our standard form quadratic equation there with the a, the b, and the c, the part of that quadratic equation that we call the discriminant is the part of our quadratic equation that's underneath the radical. So that b squared minus 4ac part of the quadratic formula is called the discriminant. And that's the part of the quadratic formula, if you're looking at it that way, that's the part of the quadratic formula that determines what type of solutions we're going to have. We haven't done some of all of them yet, but like if we look at this one we did last time, we got our numbers under there, and underneath the discriminant, or where the discriminant is, we ended up with 1 underneath the radical. So in that case, we ended up with, what did we end up with? 2 real solutions. Yep. 2 real solutions. So if the discriminant is positive, and I'll just write this down. So the discriminant is b squared minus 4ac, our discriminant. And I'm gonna, just to make it easy, I'm gonna call that d for discriminant. So if our discriminant is positive, bigger than 0, we'll have 2 real solutions. We haven't done one of these yet, but if our discriminant is negative, smaller than 0, let's look at what's going to happen. Let me scroll back to our quadratic formula here. If we have the part underneath the radical comes out negative, we're going to have a negative underneath the square root. And when we have a negative under a square root, what do we end up with there? Square root of -1 is I. So if we have a negative underneath the square root, we're going to end up with complex numbers as our solution. And anytime you have a complex number as a solution, you have 2 of those that come in a pair. Okay. So if the discriminant is negative, we'll have 2 complex solutions. And the way that WebAssign asks you about the discriminant, they ask you how many real solutions we'll have. So if the discriminant is negative, we could say we have no real solutions. And then we've got one other possibility. Our discriminant is bigger than 0, it's smaller than 0, or what? It's equal to 0. And in that case, we'll have one sort of real solution. And I say sort of because really what's going on, we have another way of thinking about it, that we get the same solution twice. We have a repeated solution. But since it's the same, it's okay for you to think about it as being one real solution. So looking at the discriminant, if it's positive, we'll have 2 real solutions. If it's 0, we'll have 1 real solution. If it's negative, we'll have no real solution. Sometimes that's all we care about. We just care about what type of solution we'll have, how many. So we don't have to do the whole quadratic formula, we can just do the discriminant part. And if you practice a little bit, you can, if the numbers are not too big, you can almost do the discriminant part real quick in your head, at least to know if it's positive or negative. And then you kind of know what to expect through the rest of the process. There's actually a pretty good bit more information you can get from the discriminant, but we won't. Those are the ones to focus on. Here's our discriminant information. All right, so let's do another quadratic equation where we solve it using quadratic formula. Let's do this one. These numbers are a little on the large size, but we'll work our way through it. Okay. Gonna do quadratic formula here. So A is going to be 4, B is going to be 32, C is going to be negative 17. So filling into our quadratic formula, it's the opposite of B, so x is opposite of B, so negative 32 plus or minus B squared. Remember, I suggest you put parentheses here because it can be a little tricky if you have a negative number for B. And then minus 4 times A, which is also 4, times C, which is negative 17, all over 2A. Okay. I'm going to break out my calculator up here. So, let's see. 32 squared, 1024. Okay. And then 4 times 4 is 16, times 17, get 272, and then we have the two negative signs, so it turns into plus 8. Okay. Then we add the 1024, add the 1024 and the 272. Hope it comes out to something nice. That's a perfect square, but if not, we'll deal with it. Let's see, I got 1296 there. And let's see if that's not one I have memorized, but let's see if it comes out. Yes, that comes out to the square root of 30, or the square root of 1296 is 36. So even though it looks scary, it works out pretty nice for us. And then we'll get two solutions. Positive number under positive discriminant, so we can expect two solutions. So we'll get one by taking the plus sign. So if we do negative 32 plus 36, that's 4 over 8. Simplifies to 1/2. If we use the minus sign, negative 32 minus 36, negative 68 over 8. Then we have to simplify there, so let's see, they're both even. Negative 34 over 4, still both even, so negative 17 over 2. Okay, so not necessarily pretty solutions, right? We get fractions. That's okay. Questions on that one? Okay. Let's do one more. I got one with small numbers. One more. Okay. X squared minus x plus 2. So what's our a going to be this time? Yeah, if there's no number there, it's a 1. And then our b, what's it going to be? Negative 1. So b is negative 1. And then c is 2. Okay. Using our formula. Okay. You don't have to memorize the formula. I'll give it to you on test day. That's fine. You can reference it when you're working on problems. That's okay. If you do enough practice, you'll pretty much have it memorized. Okay. So we want the opposite of b. And so right now b was negative 1, so we do the opposite. That's 1. Plus minus the square root of negative 1 squared. You don't put the parentheses there in your calculator, there's a good chance it's going to give you negative 1 as the answer. The answer is supposed to be positive 1. Okay. Minus 4a c all over 2 times a. Okay. So let's work our way through it. Negative 1 squared is positive 1. And then we've got minus 4 times 1 times 2, so that is minus 8 over 2. Anybody notice anything about the discriminant? About the part underneath the radical? It's going to come out negative. It's going to come out negative. So negative 7. So what kind of solutions are we going to get? If we have a negative discriminant, we're going to get complex solutions. And complex solutions. So let's talk about how to simplify in that case. Okay. We know that I is the square root of negative 1. So the way we can deal with a negative underneath the radical, we can take an I out. And so like if we take negative 1 out, square root of negative 1, that's I. Okay. Yeah. And then if we want to put our answer in a plus bi form, we got to split it up. So we'll write the 1 part over the denominator of 2. And then we'll have our plus and minus sign. Okay, the I we're going to end up just writing out to the side. Okay. Move it down to the side. So we've got square root of 7 over 2. That's our standard form on that one. That would be our 2 complex solutions. They're ugly. And it's a complex number that's got fractions and a radical in there. Ugly, but that's correct. Questions on that one? That's a little different. Got the complex number. You feel okay with that? Okay. Tricky, and that's a little different, so. Another one. Do this one. Numbers are a little bigger on this one, but we can work our way through. Okay. And so again, A is 1. This time B is 18, and positive 18. C is 82. So break out our quadratic formula. We want the opposite of B, so negative 18 plus or minus the square root of B squared, so 18 squared, minus 4 times A, C, over 2A. So another good time to break out the calculator. So 18 squared is 324. Then we've got negative 4 times 82. That'll be negative 328. I didn't know either one of those in my head. I did about those in the calculator. So if it works out, it's not too terrible. And it's radical, we have negative 4. I made that way too big. Negative 4. So then how do we deal with having a negative under the radical? We can bring an I out. That gets rid of the negative. And then we know square root of 4, hopefully. If not, punch it in the calculator. Now square root of 4 is 2. We got 18 plus or minus 2i over 2. But typically when you have an I and a radical involved in a term, you write the I in front because, this is why, okay. So a little side note here. Typically we'll write I square root of 4 because if you write square root of 4i, it's tricky to tell if the I is supposed to be under the radical or not. So that's why the I gets switched around like that. So then we can split this up. So it'll be negative 18 over 2 plus minus 2 over 2i. And then we can reduce. Negative 18 over 2 is negative 9. 2 over 2 is 1. So that's our A plus BI form. If you really want to reduce first, you see we have a common factor of 2. It's okay to factor a 2 out of the top and then cancel. Just be careful. I prefer you think about it this way because it's really tempting to like cancel this 2 and this 2. I see people do stuff like that and say it's negative 18 plus or minus I. It's not. You got to take the factor of 2 out of the 18 also. All right, what do you think? Okay. All right. Okay, so that's quadratic formula. Sometimes you do kind of get into a messy situation simplifying those things. The numbers get big and it gets a little messy, but it works. It does work. Quadratic formula works for any quadratic equation. So so far our methods we've talked about solving quadratic equations if you have a perfect square on one side. Like the first one we did where we just had x squared equals something. Then you can take the square root of both sides. Just remember plus or minus, plus and minus. If you can factor, if you can get the thing equal to 0 and then factor the other side, you can set each factor equal to 0. Solve each one of those equations, solutions. Or you can use a quadratic formula like we've done these last few. And then we got one other method we want to talk about. Gets a bad reputation. It's a very nice method. Before we get there, I kind of want to let's talk about this. There is a thing called a perfect trinomial square. It's a perfect square, but it's a trinomial. So that would look something like this. So why is that a perfect trinomial square? Let's factor it. If we factor this thing, we need factors of 9 that add up to give us 6. So what factors of 9 will add up and give us 6? 3, yeah. So plus 3, plus 3. Look what happens. Both of our factors are the same. So another way we could write this is x plus 3 squared. Perfect square. Perfect square. So these things are nice because if you know you have a perfect trinomial square, they're easy to factor. It's just square root of the first term, right, x, and then square root of the second term, and then it's squared. So it's nice. It's a little hard sometimes. You have to take some extra time to look to see if it actually is a perfect trinomial square. The way I made this one is the square root of this, or this is 2 times the square root of this number, so square root of this is 3, 2 times that is 6. So that's a little tedious to figure out. But if we're in a situation where I told you this was a perfect trinomial square, it would make it easy to factor. So we're going to use that for this last technique of solving a quadratic equation. Because what do we say we can do? If we get one side of our equation as a perfect square, then the short way of solving, we just take the square root of both sides. Take the square root of both sides. So if we can get into this situation, we just take the square root and then we're done. Pretty much. So our goal is going to be able to take something like this where we've got x squared plus some number with the x and to turn that into a perfect trinomial square by picking some number to add to it. And our magic number that we're going to add is going to be this form. Okay, we take whatever the number in front of the x is, b, divide that by 2, then square it. Now this thing is a perfect trinomial square and it's easy to factor. So that b over 2 squared number, I don't know that it has a good name. I just call it the magic number because I don't know what else to call it. Okay. If we add that magic number, now all of a sudden this thing factors really easily. It factors as x plus b over 2 all squared. And I know that it's going to do that every time if I can turn this thing into a perfect trinomial square. So using this idea where we turn one side of our equation into a perfect trinomial square and then factor, and then take the square root. The method's called completing the square. Completing the square. So that's our kind of third major method for solving quadratic equations. Completing the square. Okay. So I want to go back to one of our easier quadratic equations. We've actually already solved this one a different way, but I want to use it for our first completing the square problem. So I want to try to solve this quadratic equation using this completing the square technique. All right, so to start off with completing the square, we know we're going to have to add something to make our quadratic a perfect trinomial square. I don't want to have to think about picking the right number so that it works out right with the 21 that's there and all that. So what I'm going to do is I'm just going to move the 21 over to the other side out of the way. Okay, so I'm going to subtract 21 from both sides. And I'm going to leave some room because I know I'm going to be adding that magic number. So get just the x terms on one side. And then now I want to add my magic number, b over 2 squared. B is the number with the x. That's 10. We divide that by 2, get 5. I'm going to add 5 squared. That's b over 2. This is b. Since we were dealing with an equation now, since we've added one number to the left side of the equation, we want to keep it balanced. So if we do something to one side of the equation, we have to do it to the other side. So I'm going to add 5 squared to the other side of the equation too. And the whole reason we do that is now the left side factors really easily. Since I know that's a perfect trinomial square now, it's going to be x plus, my magic number was 5 squared. That's the left side now. We factor. On the right side, I've got negative 21 plus 5 squared. 5 squared is 25. So negative 21 plus 25 is 4. Our part's over now. Now we just take the square root of both sides. Because we got a perfect square, so we take the square root of both sides. I normally don't even write this step down exactly like this, but we will. We got to remember plus minus on the other side. On the left, the square root and the square cancel out. Leaves me x plus 5. On the other side, on this one, I can find square root of 4. Square root of 4 is 2, so on the other side I've got plus minus 2. And if I want x by itself, plus 5 right now, so to move it over to the other side, we subtract 5 from both sides. Get minus 5 plus minus 2. And then we get our two solutions. So if we use the plus sign, negative 5 plus 2 is negative 3. If we use the minus sign, negative 5 minus 2, negative 7. solutions down there. So maybe a little bit strange. It's not hard. Maybe a little strange to you if you haven't done it much or at all. So completing the square always works. Like quadratic formula, it always works. And actually the way we get the quadratic formula is we complete the square. So we take ax squared plus bx plus c, complete the square, we'll get the quadratic formula. That comes from this. Completing the square does get more difficult if our leading coefficient is not a 1. So if your leading coefficient is not a 1, okay, fine, use quadratic formula. If your leading coefficient is a 1, completing the square can be not bad. Not bad. Sometimes it's faster than doing quadratic formula. Let's do another one. That one, okay, so this particular quadratic equation, factoring is the fastest way. And we did it with factoring earlier, because we need factors of 21 to add together and give us 10, which is 7 and 3. We're practically done once we figure that out. So get them. So let's do another one where completing the square would be better. Let's do this one. Small numbers. Try to factor this one. Won't factor. You could do quadratic formula. And we're gonna do completing the square. So first step on that is I'm gonna leave just my x terms on the left side and move whatever number I have over. So subtract 1 from both sides. This one is slightly messier than the last one because when we go to add our magic number, the b over 2 squared, b 1, the number in front of the x. So we do get a fraction. Okay, we'll get plus 1 over 2 squared. And then remember, if we do something to one side, we got to do it to the other side to keep it balanced. So plus 1 over 2 squared. So that is a little bit annoying. We have a fraction. But the left side, now we can rewrite it. X plus the magic number 1 over 2 squared. On the right side, we've got a little bit of work to do, and because of the fraction. So we got negative 1. If you square a fraction, you square the top and square the bottom. So it's plus 1/4. And if you're intimidated by fractions, you might not like that. We got to get a common denominator. That'd be negative 4 over 4 plus 1/4. You could use a calculator. I don't know if you know how to do fractions on the calculator. That's negative 3/4. So equals negative 3/4. We take the square root of both sides. On the left, just leaves us with x plus a half. All right, we got plus minus square root of negative 3/4, which is a little messy. But we can simplify it. It's negative, so I'm just copying the left side down. It's negative, so we can solve that by bringing an I out. And if you want to take the square root of a fraction, take the square root of the top over the square root of the bottom. So square root of 3 over square root of 4 is 2. And we're pretty much done now. Now we just need to move our 1/2 over. So subtract 1/2 from both sides. So minus 1/2 plus minus square root of 3 over 2. Yeah, it was a little messy, but that was because we had a messy answer. If you do quadratic formula, you get a messy answer on that one too. Just pick your poison on those. Would you rather do quadratic formula or would you rather complete the square? There's still no one? Nothing? Okay. Let's look at one more. And not necessarily completing the square, just another quadratic equation. Quadratic equation. Here, I'm going to give you a minute to work on it, and all I'm going to tell you, I'm going to say solve. I'll even say solve for x. So pick whatever method you want. Remember, factoring doesn't always work, so may or may not be an option. Or you can do quadratic formula, or you can complete the square. Maybe. This is probably not, yeah, this is not really a prime candidate for completing the square because we've got a 2 in front of the x squared. So probably factoring or quadratic formula will be the easiest. I'll give you a minute to tack away at it, and then we'll try it. If you need it, here's quadratic. So either way you do it, first thing we got to do is get everything on one side. And yeah, I think this one. Anybody do this in factoring? Everybody, okay. All right. So we'll do quadratic formula then. So A is 2, B is -5, C is -3. Okay. So 5 plus or minus square root of 25 minus plus 24 over 4. That's the square root of 49, which is 7. So what do we get? So we get 2. Well, you don't even have to do it that way. We got 2 solutions, and if we use the plus, 5 plus 7 is 12 over 4, which is 3. Use the minus. 5 minus 7 is -2 over 4, which is -1/2. Is that right? You guys get that? Okay. Yep. The signs give you trouble? You might catch a sign there you did? Not come clean about it, huh? Not all these, somebody made a sign here. Do I need to back up? Okay. Okay, so next section, we're going to do just a little bit of it. Next section, we've got just other types of equations to solve. And we're really going to have 3 types. We're just going to do one today. One for today. So at least we get away from quadratics, right? Something to be positive about. We get away from quadratics. I know it's kind of boring having a whole section on quadratic equations, but they come up a lot in a bunch of different applications. You need them. You need to know how to solve them. All right, so 1.6 is just called other types of equations. We're going to have 3 types that we talked about. On the one that we're going to talk about today, we're going to talk about solving radical equations. And so when we have a variable underneath a radical, okay, how do we deal with that? We'll get to the next two, the other 2 next time. Okay. So let me get this one here. I don't want to just make a random one and it come out real nasty. So let me get a good example one to first use here. And bear with me 1 second. take a minute and imagine you're at the beach or the mountains, whichever one. If you're a mountain person, that's okay. For shopping, fishing, but whatever you like to do to relax. Hey, let's look at this one. That's what I'm talking about when talking about radical equations. So we have a variable underneath the radical, and in order to solve to get x by itself, we've got to get it out from there somehow. So how can we do that? Ideally, we would have some kind of operation we could do to both sides that would cancel out the square root on this one. So you know any kind of math operation that would cancel out a square root? Square, yeah, we could square. So what we can do, we've got a square root, so we can square both sides. So raise both sides to the second power. Before we do this, we already had it in this situation, but before we do this, we want to make sure we've got our square root by itself. That way, when we square the side with the square root, it just cancels out the square root. If we had some other term over here outside of the square root, then we would have to do FOIL method and it would get messy. So we want the square root by itself, and then we can square both sides. So here, if we square square root, it just leaves us with what's underneath. On the other side, if we square the 5, we get 25. And from there, it's just a nice little linear equation. Trying to get x by itself, so we add 1 to both sides. And then we've got 6 times x equals 26, so we can divide both sides by 6. And then that will simplify. So this one didn't come out nice, but that's okay. We got 13. Nothing horrible. It's just really that first step. The first couple of steps, we get the radical by itself, raise it to the appropriate power to cancel it out, raise both sides to that appropriate power. I think, let me double check. Yeah, the only ones I've got for us to do are square roots. So you can do the same thing with the cube root, right? You just cube both sides. It just gets messier. You get bigger numbers. Do another one. Let's do Okay. This one's a little different. We've got square root of x plus 20 equals x. So a little different because we don't have a number on the other side. We've got a variable. We use the same strategy to start off with. We got to get rid of that radical so we can get our variable out from underneath it. So the square root, so we'll square both sides. On the left, that leaves us x plus 20. What do we get on the right side? If we square x, we get x squared. Okay, so that's fine. It's not quite as easy as the last one. Because we don't have a linear equation, we have a quadratic. But, well, we just spent the whole section solving quadratic equations. So we need to get it all on one side. It's all on one side. So I like having my x squared coefficient positive, so I'm going to move everything over to the right. That'll be minus x minus 20. And then what are our options? Sometimes we have too many options and it makes us kind of stall out. What could we do? We could look to see if it will factor. So we need factors of negative 20. That will add up to negative 1 in the middle. If you think about that for a second and you can think of them, factoring is a good choice. Yep, that's it. Okay. If that doesn't come to you, or you don't want to spend your time trying to figure that out, quadratic formula is a good choice. You just have some extra simplifying you might get involved in. Or on this one, we could even complete the square. Wouldn't be bad to complete the square. Good fraction involved, but not horrible. So I'm going to factor it because factors kind of jumped out to me. So factors of negative 20 that add up to negative 1. So negative 5, positive 4 will give us negative 20, and negative 5 plus 4 will give us negative 1 in the middle. Once we have it factored, we have that property of a product equaling 0 that we can take each factor and set it equal to 0. Get two solutions there. X equals 5 equals negative 4. And I got a little ahead of myself there. There's two solutions. We got one other thing we got to be careful about. So when we do this thing where we square both sides, that means we need to be extra careful to check our solutions. Because sometimes when we square both sides, we introduce what we call extraneous solutions. So what that means is that we can do the algebra perfectly correct, but when we get to the end, maybe one or more of our solutions don't actually work when you plug it back in. That's a possibility. And that happens when you raise both sides to an even power. If you raise both sides to an odd power, you don't have to worry about it. Since we're squaring both sides here, we need to be extra careful to check both of our solutions. So here's our check. So here's our original equation again. So let's try the 5. If we try the 5, does that equal 5? Square root of 25. Yeah, that checks out. So 5 is a good solution. Try the 4. What about that one? The square root of 24, 4. No. That one's no good. So x equals 4, we throw that one away. That's not an actual solution. That would be an extraneous solution is the fancy term. Oh, it's supposed to be negative 4, wasn't it? Sorry. It doesn't work either way, but so here we do -4. Or does it? Oh no, because it's -4 over here. That actually makes it even easier there. Because why? That's not going to work out because on this side we're going to get square root of 16 equals -4. It's not going to be negative. It's going to be +4. So those don't work. Sorry about that. Questions on those? Not bad. All right. That's it. Out here. Good day. Okay. We'll finish up. We'll do our other two types of equations next time. Okay. If you didn't get on the sign-in sheet, make sure you get on there before you head out. If you have any questions about anything, I'm up here, so feel free to come talk to me.